A very good morning to one and all. So in this class we are going to discuss about energy. Yes. So what is energy? The ability to do the work is called as the energy. So energy is of two types. One is potential energy, another one is kinetic energy. And this potential energy is going to split into two. One is gravitational potential energy, another one is elastic potential energy. Now, what is the definition of potential energy? So potential energy is nothing but an object has a stored energy due to its position or state. I will give you an example. Think of a ball which is kept on a table. If you are not touching the ball, it is going to be on the table. But if you are going to move the ball, that ball is going to fall from the table and it is going to break something. But if you are not moving the ball is going to be on the table only because it has the stored energy due to its position. So that is what the potential energy. Once if you move the ball, it is going to be in motion. That movement is called as the kinetic energy. So this is what the difference between the potential energy and the kinetic energy. So potential energy is the stored energy at rest and kinetic energy is active energy in motion. So it is the types of energy, kinetic and potential energy. So energy is split into two, potential energy and kinetic energy. This potential energy is split into gravitational potential energy and elastic potential energy. So as I already explained you, so potential energy is nothing but an object is a stored energy due to its position or state. And this potential energy mostly depends upon the mass and the height of the object. Higher the mass, higher the object, the more potential energy it has. Yes, as I already explained you, when this potential energy is going to convert into kinetic energy is when the object is at rest. That stored object, when it's begin to move to that place to another place, that conversion is called as the kinetic energy. And this potential energy is split into gravitational and elastic potential energy. The example for gravitational potential energy is water at the top of the waterfall. So in this, the water, it has a stored energy due to its height above the reference point. So this is what the example of the gravitational potential energy. And then for elastic potential energy, there are 2-3 examples. So first example is stretched rubber band. So stretched rubber band, it is a potential energy due to its stretch position. It has a stored energy while stretching. It has a stored energy. So it is in the stretching position. Once if you let go, it is going to snap off. So it begin to move. That movement is kinetic energy. So when you are stretching this is a picture. For example, you are stretching this rubber band. So it has a potential energy because stored energy. When you let go, it is going to come out. It has a stretching position due to its position. Okay. And another one is this spring. This spring you are going to expand. So this has a potential energy due to its position. If you leave off, it is going to come back to its original position. Another one example for elastic potential energy is this bow and arrow. Imagine the spring, it has a potential energy. It has a potential energy and it has stretched. It is stretched in its position. So it has a potential energy. Now this as the energy of the string has to go from one place to another. This work has to be done. So what is the role of the bow and arrow is you are going to stretch it and you are going to leave that arrow and it is going to point on some other place. So likewise in this elastic potential energy, when you are going to stretch the spring, it has a potential energy. Now the work has to be done. For the work has to be done, the potential energy has to, it is in position, but you have to let go. Only if you have to let go, it is going to transfer from this place to that place. So this is what the potential energy. So potential energy is nothing but an object has a stored energy in its position or state. Kinetic energy is the active energy is begin to motion. So that is what the difference between the kinetic and the potential energy. Next we will discuss about the potential difference and electromotive force. So what is the difference between these potential difference and electromotive force? In potential difference, you are going to see how much energy has been used. In electromotive force, you are going to see how much energy has been supplied throughout the circuit. So in potential difference, you are going to observe how much the energy has been used between the 2 points. In electromotive force, you are going to see how much the energy has been supplied throughout the circuit. So this is what the difference between the potential difference and the electromotive force. So likewise, the potential difference is in a closed circuit, you are going to observe how much energy has been used between the 2 points of the electronic circuit in a closed circuit. And in electromotive force, in open circuit, you are going to see how much energy has been supplied throughout the circuit. And another difference is, this is totally depend, this potential differences depend on the resistance and it is directly proportional relationship. But in EMF, it does not change with the resistance of the circuit. And this potential difference is always lesser in the EMF, but in EMF, the electromotive force, the value will be higher. And in potential difference, it will be work under the electric fields, but this will work under the electric, magnetic and gravitational field. And the potential difference is considered as the effect of EMF, and this is the cause of the charge separation. So this is what the difference between the potential and the electromotive force. So potential is nothing but it is how much energy has been used between the 2 points in a closed circuit. In electromotive force, there is a difference in the how much charge has been used, how much energy has been used throughout the circuit. And this is depend on the resistance, and this does not depends on the resistance. And this has less EMF, this has the more EMF, and it is work under the electric field, and this works under the magnetic and the gravitational field. And this potential energy is the effect of the EMF, and this it does not causes the separation, charge of the separation. So this is the formula. Potential difference is equal to V is equal to W by Q. So V mentioning the potential difference between the 2 points. W is the work done to move the charge between the how much energy has been used between the 2 points, and Q is the charge to be moved against the electric field. So this is the formula we will be using for the potential difference. And then next we will move on to a new topic called capacitor. So capacitor is otherwise known as the condenser. This capacitor is what is the role of the capacitor is, it is a device to store an electric charge. So next we will see about the construction of a capacitor. So in construction of capacitor, there are 2 metal plates which are placed close to each other. But these 2 metal plates will place close to each other, but it will not touch, it will not intersect, but it will be close to each other. In these 2 metal plates, in between it is separated by a insulating material called dielectric. So this is what the construction. So in capacitor you are going to see there are 2 metal plates which are placed close together, but it will not touch each other. In between it is separated by a insulated non-conducting insulating material called dielectric. So this is what the capacitor. This is a 2 charge, positive charge and negative, 2 metal plates. These are the 2 metal plates, and in between it is separated by a dielectric. And this is what the 2 metal plate. This is 2 metal plate, and in between it is separated by a dielectric, and it is enclosed by the insulation, plastic insulation. Yes. How this capacitor? What is the principle of this capacitor? Yes, so this capacitor will mainly work on the electrostatic storage of the principle. So what is this electrostatic storage is? It is nothing but, this will be work on the example. You can take an example like, imagine there is a small tank. In that tank, you are going to store all the electricity and you are going to give it whenever it is needed. So like example like water tank. So water tank, you are going to save the amount of water in the tank, and whenever it is needed, you are going to open the tap and you are going to use that water. So likewise, in this capacitor, you are going to store all the electric charges and it is going to be saved. And whenever it is required, you are going to release that flow of current, and it has to be used at the further purposes. So this is what the capacitor. So it will work under the electrostatic principle, electrostatic storage of principle. So what are the different types of condenser? So fixed condenser, variable condenser, paper condenser, mica condenser, air condenser, electrolytic condenser. So these are the different type of condenser. When it has been used means, as already told you, in construction of condenser, there are two metal plates which is separated by a non-insulating material called dielectric. So the dielectric, it contains these type of condenser. For dielectric substances, you are going to use different type of the condenser. That is condensers are called as capacitor. These type of capacitor, different type of capacitor, you are going to use as a conductor. That is dielectric. So construction I have explained you. So in this construction, they are explaining about the, yes. So these are the two plates. One is positive charge and this is a negative charge. These are the electric field, and this has to be, these are the two are the charged conductive plates. Yes, another thing I want to tell you in a detailed construction of a capacitor. So there are two metal plates. These two metal plates are the good conductor of electricity. So if it is a good conductor of electricity, what will happen is the current will be easily passing through them. But in between, the dielectric is a bad conductor, it is a poor conductor of electricity. So if it is a poor conductor of electricity, it will prevent the electricity to flow through the circuit. So why it is preventing? Because the capacitor role is it is going to store the current, and it is going to be released whenever it is required. So this is what they are in construction of capacitor. They are mentioning that the two plates, they are the good conductor of electricity because it is going to flow allow the current to pass on through the circuit. But this dielectric is a poor conductor of electricity. Why? Because it is preventing the current flowing through the circuit. Yes, so how this capacitor works? Like when voltage is applied across this capacitor, one plate will become a positive charge, another plate will become a negative charge, and in between the dielectric will prevent the current from flowing the circuit to the another one. And when this capacitor is again connected to another circuit or another load, that stored current is going to ready to flow and the stored current is going to release. So this is what the outline of the capacitor working. Yes, and this is a symbol of capacitor circuit. Okay, so this capacitor symbol is represented by drawing the two parallel lines closing to each other. It consists of two terminals. It is used to connect the circuit. Yes, next we will discuss about the charging of capacitor and uncharging of capacitor. So in charging of capacitor, what will happen is when the capacitor is connected to a power source, what will happen? The voltage is applied. So when the voltage is applied, there will be a transfer of once the voltage is applied, the one plate will become a positive charge, another plate will become a negative charge. Then the battery will be pushes the charges continuously. It will be pushes the charges until the battery voltage and capacitor voltage, until it gets equalized. It's going to push the electrons continuously, and this dielectric is going to protect and store the electric charge. So charging of capacitor is nothing but storage of the electric charge. So what is the discharging of capacitor? It is like you are going to release the stored electric charges, electric current. You are going to release the stored electric charges. That is when it is going to release your electric charge. When you are going to release the stored current to a release purpose, means that is when the capacitor is connected to another device or another circuit. That time what happens? The stored energy is start to flow. Once it start to flow, the current will automatically it's getting released. So this is what the discharging of capacitor. So that's all for today's class. Remaining we will discuss in next class. Thank you.